Hello, this is Pre-Cal Homework Solutions 1.9b, where we're going to work worksheet 1.9, 11 through 18. So these first four are the sum or the difference of two perfect cubes, so we're going to use that formula. So for number 11, A, all right, what is the cube root of 64? Well, if you don't know that, you can use your calculator, but it is 4. 4 cubed is 64. And then the cube root of y cubed would be y. And then for 27, b is going to be 3. So our factoring formula, we're going to have a minus b, so 4y minus 3. First term is a minus, since it's a minus there, times a squared, that's going to be 16y squared, plus ab, so that's going to be 3 times 4y, that'd be 12y, and then plus b squared, so 3 squared is 9. All right. Okay, for number 12, a is going to be the cube root of 8 is 2, and then the cube root of x cubed is just x. And then b, the cube root of 343, we've seen that in our lecture, is 7. Okay, it's a plus, so our first term is going to be plus, so 2x plus 7 times a squared, so 2x squared would be 4x squared, minus ab, so 7 times 2 is 14, so minus 14x, and then plus 7 squared is 49. All right. So make sure you show the A and the B on your homework and on the test. All right, number 13, we've got one of these kind of special ones where A is just going to be u plus 2p. You take the cube root of that, you'll get u plus 2p. Now 512, if you take the cube root of 512, so in your calculator put 512 to the 1/3 power, you will see that it is 8. All right, so b is equal to 8. So if you're not sure, you can use your calculator on that part. It's a minus there, so our formula will be, we're going to use bracket, u plus 2p plus 8, and then close the bracket, and then it's going to be a squared, so u plus 2p all squared, or excuse me, this is a minus here. I apologize, that's a minus. So it'll be a plus here, and then it would be plus a times b, so 8 times u plus 2p, and then 8 squared is 64, so plus 64. All right. So on number 14, so we have 3t plus r cubed, that's going to be a, so a is 3t plus r, take the cube root of that, and then b would be 5. 5 cubed is 25. So it's a plus, so we would have 3t plus r plus 5, and then times quantity 3t plus r all squared, minus 5ab, so 5 times 3t plus r, and then we would have plus 25. All right, so 5 squared is 25. So, all right. So for number 15 through 18, we're combining computational techniques. All right, so you see 4 terms and think, all right, maybe we need to try grouping. So we could factor out a 2x to the 5th for the first two and a 5x for the second two. So that would leave, we'll factor out that greatest common factor, 2x to the fifth. That leaves x squared minus 3. And then hold off here. We've got a 5x, so that's going to be x squared. And then, once again, minus 3. And I would need a plus here to make that term plus right there. I need a plus there. So we've got 2x to the fifth plus 5x times x squared minus 3. Now, that 3 is not a perfect square, so we're not going to factor that anymore. But we can, and of course you could put x plus root 3, x minus root 3, but we don't do that. It would work, but it's not improving things. We can factor an x out of that first term. So we'd have an x, and then you would have 2x to the fourth plus 5. So what makes it simpler is we're able to take it down an exponent there, times x squared minus 3. All right, so on our examples in the lecture, we had a couple of differences of perfect squares, but didn't have that one here. That's okay, don't force it. We'll just leave it like that. All right, give me just a second to erase. This video is going to go pretty fast, I think. Okay, so we've got 16. We've got 4x to the seventh minus 4x to the fifth plus 5x to the fourth minus 5x squared. So 4 terms. Let's see if we can group. So I could factor out a 4x to the fifth out of these two and a 5x squared out of these two. So 4x to the fifth out of those first two, and you're left with x squared minus 1. And then 5x squared, and it's going to be x squared minus 1. So putting those together, we have 4x to the fifth. And right here, our sign, in order to make it plus, need a plus there. So 4x to the fifth plus 5x squared. Not quite done with that one. Times x squared minus 1. Okay, we could factor out an x squared here, so that would leave 4x cubed plus 5. And then x squared minus 1 is the difference of two perfect squares, with a is x and b is 1. So we'd have x plus 1 times x minus 1. All right. I kind of enjoy these. I don't know why, it just kind of seems a nice little systematic way of doing math. All right, number 17, we have 3x to the seventh minus 12x to the fifth plus 5x to the fourth minus 20x squared. So once again, looks like a grouping situation. At least that's a good place to start. All right, and a 3x to the fifth, we should be able to factor that out of that first group, and then a 5x squared out of the second group. So we've got 3x to the fifth, and what's left would be x squared minus 3 goes into 12 4 times. And then we would have over here a 5x squared, and that's going to leave, should be x squared minus 4 again. Usually with grouping, of course, you want to have the parenthesis quantity to be the same, and 20 over 5 is 4, so that'll work. Put a plus there, because when you distribute, that'll give you the plus minus you want. So we'd have 3x to the fifth plus 5x squared times x squared minus 4. So we could factor out an x squared here, and I would have 3x cubed plus 5. And then this x squared minus 4 is the difference of two perfect squares. So a is x, b is 2. So that'd be x plus 2 times x minus 2. All right, so getting to do a lot of good factoring techniques with these three. All right, I'm going to see if I can fit number 18. Let's squeeze it in over here. So 18, we have x to the 15th minus y to the 18th. Well, I told you in the lecture, anytime that you have exponents that are multiples of 3, you could rewrite them as a cube. So how about we rewrite this as x to the 5th cubed minus y to the 6th all cubed. Now we have two perfect cubes. 6 times 3 is 18, 5 times 3 is 15, and we can use our difference of two perfect cube formula where a is equal to x to the 5th and b is equal to y to the 6th. So we could factor this as a, it's a minus, so a minus b, so we'd have x to the 5th minus y to the 6th times a squared, x to the 5th squared is x to the 10th, so that's when you multiply. And then it's a plus x to the 5th times y to the 6th, so plus ab, and then plus y to the 6th squared, so that would be y to the 12th. All right, that's pretty cool. Something like that looks impossible to factor, but hey, we can use math to our advantage with a little bit of trickeration, and that makes for some cool factoring. All right, that'll do it for this homework solution set. I will talk to you on the next one.